All right, let's dive right in. Today, we're taking a look at one of the most incredible networks inside every single one of us, the cardiovascular system.
Have you ever just stopped for a second and really thought about that constant beat in your chest, that lub-dub sound we all know? What's actually going on in there?
Well, that sound is the engine of your body's very own internal FedEx system. Yep, it's a super efficient delivery service that is working nonstop, 24/7, to keep you alive and kicking.
So what does this internal delivery service actually do? As we're about to see, it is so much more than just a simple pump.
Okay, so at its core, the cardiovascular system is this massive network. It's made up of three key parts, right? You've got the heart, the blood vessels, and the blood itself. And its main job is pretty simple: deliver the good stuff and haul out the trash.
But the variety of jobs it does is what's truly mind-blowing. This system isn't just dropping off oxygen and nutrients. Nope. It's also your garbage disposal, getting rid of waste like carbon dioxide. It's your thermostat, regulating your body temperature. It's your mail carrier, delivering important messages with hormones. And it's even your security force, deploying immune cells to fight off infections. A real multitasker. So who are the key players making all this magic happen? Let's meet the different parts of the system, and we'll start with the cargo itself, your blood. You know, blood is this fascinating cocktail. The liquid base is called plasma. It's mostly water. Then you have the heavy hitters. The red blood cells are your oxygen couriers, and they get that red color from a protein called hemoglobin. The white blood cells, they're your personal bodyguards. And then you have platelets, the unsung heroes who rush in to patch things up whenever you get a cut.
Now, let's clear up a really common myth. Despite what you see in all the textbooks or that bluish tint of the veins on your wrist, your blood is never, ever blue. It's always red. It might be a darker, deeper red when it's low on oxygen, but it is always red. That blue you see is really just an optical illusion, and it's a super handy color coding tool for diagrams.
So, how does all this blood get around? Well, it travels through a massive highway system of arteries and veins. And when I say massive, I mean it. If you stretched out all the blood vessels in your body, they'd circle the Earth more than twice. And here's the easiest way to remember the difference. Arteries carry blood away from the heart. See? A for arteries, A for away. Veins bring it all back. And because arteries are handling blood under high pressure, pumped straight from the heart, their walls are way thicker and more muscular than the walls of veins. Okay, let's put this all together. We're going to take a little journey through the heart, following a single drop of blood as it makes its rounds.
First, let's get the lay of the land. The heart has 4 chambers, 2 up top called atria, and 2 on the bottom called ventricles. Here's a little trick. In the alphabet, A for atria comes before V for ventricle, so the atria are always on top. And separating these chambers are valves, which are basically just one-way doors that stop blood from flowing backward.
Okay, here we go. The journey begins on the right side. All that oxygen-poor blood, coming back from its trip around the body, flows into the right atrium. The atrium gives it a little squeeze, pushing it through the tricuspid valve and down into the right ventricle. Then, the more powerful ventricle contracts, sending that blood out through the pulmonary valve for a quick pit stop in the lungs. And this brings us to the pulmonary loop. This is where the magic happens. In the lungs, the blood drops off all its carbon dioxide cargo and picks up a fresh supply of oxygen. And this is that one huge exception to the rule we just talked about. The pulmonary artery carries deoxygenated blood away from the heart. And in a minute, we'll see the pulmonary veins carry oxygenated blood back to it. So now we're fully oxygenated and ready to go. The blood comes back to the left side of the heart, into the left atrium. From there, it passes through the mitral valve into the left ventricle. And this chamber, the left ventricle, this is the powerhouse of the heart. It has to be the strongest because its job is to give one massive pump and send that fresh, oxygen-rich blood out through the aorta to the rest of your body, from your brain all the way down to your toes. But what actually tells the heart muscle when to squeeze? We've talked about the plumbing, so now let's look at the electrical grid that powers this whole operation. Every single heartbeat is triggered by an electrical signal that follows a super specific path. It starts at the SA node. That's the heart's natural pacemaker. It then travels to the AV node, which acts like a gatekeeper, pausing the signal for just a split second. Then it sends it down the bundle branches and out through the Purkinje fibers, which tells the ventricles to contract. And if you need a way to remember that order, SA node, AV node, bundle branches, and Purkinje fibers, try this. Strong arteries benefit the body's performance. And here's where it gets absolutely brilliant. The heart has a built-in backup plan. Actually, a couple of them.
If the main pacemaker, the SA node, ever fails, the next stop in line, the AV node, can take over, just at a slightly slower pace. And if that fails, the Purkinje fibers can step in as a last-ditch effort. It's an incredible fail-safe system to make sure the beat goes on no matter what.
Now, all this pumping and squeezing, well, it generates pressure. So let's connect all this to a number you've definitely heard at the doctor's office, your blood pressure.
So you always get two numbers in a blood pressure reading, right? The top number, the systolic pressure, is the peak pressure right when your heart contracts and pushes blood out. The bottom number, the diastolic, is the pressure when your heart is relaxed and refilling between beats. Together, they give a great snapshot of how hard your heart is working.
For most healthy adults, a number around 120/80 is considered a pretty good target. You can think of it as a quick report card on how efficiently your entire cardiovascular system is running. It's really a key indicator of your overall heart health.
Of course, a whole bunch of things can affect how well this system performs. Our lifestyle choices, what we eat, how much we move, things like smoking, they all play a huge role. But so do our genetics, the natural process of just getting older, and other diseases.
And that kind of brings us to a final thought. Your heart is going to beat trillions of times over your life. This incredible, resilient system works tirelessly, without a single day off. It just makes you wonder, what keeps this vital lifeline running so smoothly for an entire lifetime? It's really a testament to the remarkable engineering inside all of us.